Hi, a very good evening to everyone. This is lecture 2. So we will continue after the Chomsky hierarchy. So let's revise the first lecture. So first lecture we have discussed finite state machines, examples like elevators, switch circuits like fan or lexical analyzer, our computing device, human brain. These are all examples of finite state machines. And then we have discussed about um, the Chomsky hierarchy. What is the theory of automata and formal languages? Like the study of we have discussed about the computing device, uh, which is a which is a combination of or which is a combination of hardware and software, and hardware is related to the theory of automata, and software is related to the theory of formal programming languages. So now we'll continue the lecture one. This is lecture 2. In this lecture, we will discuss about the alphabet, strings, and the languages, power of alphabet, and the introduction of DFA. So alphabet, these are the basic, these three things are the basic components of deterministic, or you can say finite automata. Okay, I'm not talking about particularly about DFA. Finite automata, and this is the three basic elements of finite automata, every finite automata. Okay, we will study the decompositions of finite automata after this lecture. Okay, after in lecture 3. So alphabet, so from the very beginning, symbol, the first basic element, or you can say the building block of finite automata machine is symbol. This is the symbol. In symbol we have numbers from 0 to 9. We have lowercase letters, A to B. We have uppercase letters. We have some special symbols. So these are called symbols. Okay. So now alphabet is a set of finite non-empty set of symbols. So alphabet हम लोग किससे बनाते हैं? Symbol से बनाते हैं. Okay, symbol alphabet क्या है? A set of finite non-empty set of symbols. So we can take uh, we can take symbols for alphabets. Okay, alphabet से हम लोग symbols से हम लोग alphabet बनाते हैं. After that we have strings. So a finite sequence of symbols chosen from alphabet. So suppose we have a alphabet A comma B. So through A comma B we have to build a number of strings. So finite sequence of symbols. So string is a sequence of symbols जो हम लोग अल्फाबेट से चूज करते हैं. फॉर एग्जाम्पल आपके अल्फाबेट में अभी दो सिंबल्स है A and B. So you have to build the strings using the alphabet A and B. Okay, using the symbols A and B. So that is why we called it as strings, a finite sequence of symbols chosen from alphabet. Now after the strings we have language. Language again, it is a set of strings, all of which are chosen from the power of alphabet. Like we will discuss about this particular symbol. Language is a set of strings. Okay, so if you look into this hierarchy very closely, so this is symbol. So symbol alphabet is made up of symbols, string is made up of alphabets, and language is made up of strings. So basically alphabet is a set of symbols, string is a set of alphabet, set of a sequence of symbols chosen from the alphabet, and language is a set of strings. Okay, uh, uh, which is chosen from the alphabet itself. Okay, I will discuss this about this operator star. Okay, so now let's talk about the power of alphabet. Okay, because this symbol is considered as alphabet, so we will discuss the power of alphabet. Now suppose alphabet, alphabet kya hota hai? Alphabet is a set of symbols. Okay, so alphabet is a set of symbols. So now we have alphabet here, A comma B. Okay, so A and B are the symbols, and alphabet is A or B. So now the summation star, this summation, this sign, power of 0. Power of 0 means all the length of the string over this alphabet 0. Okay, so obviously हमारे पास अभी जो जिसकी लेंथ, जो भी स्ट्रिंग है जिसकी लेंथ 0 है, वो आपका एप्सिलॉन होगा, जिसको हम नल बोलते हैं, ओके, जिसको हम एप्सिलॉन बोलते हैं डीएफ फाइनाइट ऑटोमेटा में. नाउ पावर 1 मींस द लेंथ ऑफ 1, इट मींस वो क्या आएगा, a comma b, okay, 2 की पावर 1, because why it is 2, because we have two symbols in the alphabet, and here 2 की power 1 which is 2, it means two strings will be there of length 1, तो दो strings आई हैं a और b जिनकी length 1 है. So now power 2 means 2 की power 2, it means we have two symbols which is a comma b, उसकी power 2, it means 4, so we have four strings of length 2, so a b b a b b, okay. Meanwhile, suppose if I consider epsilon power 3, so it means 2 ki power 3, 2 ki power 3, it means 8 strings of length 3. So same with this, so if we take the union of all these things, so epsilon 0, then if we take summation 0, power 1, union with power 2, union with power 3 till power n. So these are all set of all strings over an alphabet. मतलब इस alphabet पे जितनी भी string बन सकती है, वो आप इस समेशन, इस स्टार वाले सिंबल में आप इसको कंसिडर करोगे. लाइक सो दैट इज व्हाई दिस स्टार, यू नो, दिस स्टार इज length of 0 means this is epsilon union length of 1 a comma b union length of t which is a b a union length of 3 up to n. So all the languages is what, the sequence of strings, okay. All the languages set of strings जिसको हम लोग बोलते हैं, all the languages is a subset of this, okay, it is a subset of this. Now this is what we call the star, what we call the clean closure. Okay, I will discuss this later. This is clean closure and this is positive closure, okay. So this clean closure is a union, it means clean closure में आपका epsilon considered होता है because उसमें power 0 considered होती है. But when I talk about the positive closure में आपका 0 power, it means epsilon consider नहीं होता है. So this is the positive closure, this is the clean closure. So clean closure is a union of the positive closure union with epsilon, because आपका clean closure में star में आपका epsilon consider किया जाता है, okay. So let's go to the division of finite automata. So in finite automata, we have 5 different machines. So the division is like this: finite automata with output and finite automata without output. So with output means we have two machines, okay, जो आपकी machines आपको output देंगी. We have Mealy machines and another we have Moore machines. And वो machines जो आपकी output नहीं देगी, वो सिर्फ ये बताएगी कि string आपकी accept हुई है या रिजेक्ट हुई है. वो आपको कोई आउटपुट नहीं देती है, वो सिर्फ ये बताती है आपने जो भी स्ट्रिंग आप उस पर इनपुट करोगे वो आपको बताएगी क्या वो रिजेक्ट हुई है, क्या वो एक्सेप्ट हुई है. सिर्फ एक्सेप्टेबिलिटी वो आपको बताएगी वेदर द स्ट्रिंग इज रिजेक्टेड और एक्सेप्टेड बाय द मशीन, ओके. सो वो मशीन्स आपकी कौन सी होती है, एनएफए, डीएफए, एप्सिलॉन, एनएफए. So these are the machines which is without output. Mealy and Moore are with output, okay. So let's introduce our next topic is DFA, which is the first topic of unit first. Before this, we are just I'm just introducing the subject, about the subject. Subject क्या है, क्या क्या चीजें important है वो मैंने आपको बताया. But now officially your unit start with the deterministic finite automata. So what we were discussing so far is about the prerequisites of the subject, okay. So now DFA is the deterministic finite automata. As I have already discussed with you that this machine is without output. It means it only recognize whether the string is accepted or rejected, okay. So deterministic finite automata is the most basic model of the computer, okay. Computer device का सबसे basic model जो है वो आपका DFA है. Definitely it has the less memory, इसकी less memory है. And one more thing, it involves, you know, states. It involves states and the transition, which is very important. States, we have accept, whether the state is the accepted state, you know, it or the rejected state, like the intermediate state. मतलब या तो आपकी accept होगी, final state होगी, या वो string आपकी reject होगी. Transitions, so we have a transitions among states, okay. मतलब transition means एक स्टेट को इनपुट देने पर वो कौन सी स्टेट पे जा रहा है, ओके, फिर वो कौन सी स्टेट पे जा रहा है. सो इन रिस्पॉन्स ऑफ द इनपुट्स, मतलब जो इनपुट जा रहा है उसके अकॉर्डिंग वो कौन सी स्टेट पे जा रहा है, वो आपकी ट्रांजिशन है. सो दिस इज इंपॉर्टेंट, स्टेट्स एंड इट्स ट्रांजिशंस. ओके, so this is the strings, like w we denoted as a strings, this is a string. So if see, look into this, if except state, like if the state is the final state, so string is recognized by the finite automata, otherwise rejected. Like अगर आपकी जो string है, given string है, वो final state तक पहुंच जाती है, if it is reached to the final state, so the string is accepted. Otherwise अगर वो final state तक नहीं पहुंच पाती है according to the language, so वो reject हो जाएगी. So that's what I am saying, it definitely not gives any kind of output. It only recognize whether the string is accepted. Accept कब होती है स्ट्रिंग, जब वो फाइनल स्टेट तक पहुंच जाती है. अगर वो फाइनल स्टेट तक नहीं पहुंच पा रही है तो वो स्ट्रिंग रिजेक्ट हो जाएगी. दैट्स अ simple answer. Okay, so now let's consider this. See, look into this. This is the start state, which we called it as an initial state. कोई भी स्ट्रिंग अगर स्टार्ट स्टेट से आपकी फाइनल स्टेट, दिस डबल सर्कल इज द फाइनल स्टेट. कोई भी आपकी स्ट्रिंग मतलब ये जो मैंने ऊपर डिफाइन किया, w इज इक्वल टू a1 a2 टिल an, इट इज जस्ट एन एग्जांपल. कोई भी स्ट्रिंग अगर आपकी इनिशियल स्टेट से, इस स्टेट से फाइनल स्टेट तक पहुंच जाती है, so that means that the string is recognized by the finite automata, therefore it is accepted. अगर वो नहीं पहुंच पाती है, otherwise it is rejected. Okay, so let's discuss about the formal definition of DFA, which is deterministic finite automata. So this is, this has a 5-tuple definition, which contains q, it is a set of all states. It is a set of all states. जितने भी आपके एक फाइनाइट ऑटोमेट, एक डीएफए में जितनी भी स्टेट्स होंगी, वो आपका सेट ऑफ ऑल स्टेट्स. Now we have summation, which is the input alphabet. We have initial state. q naught belongs to, obviously initial state आपका set of state में आएगा. Then we have a transition function, which is very important. I will discuss this transition function in the next class. So this transition function, it means that on given state, on present state, on given input, वो कौन सी state पे transition कर रही है. Okay, so on given state with present input, it transition to which state. Okay, it transition to another state. एक स्टेट को एक इनपुट देने पर वो एक ही स्टेट पे ट्रांजिशन करती है, इसको हम ट्रांजिशन फंक्शन बोलते हैं. F is the set of final state, obviously accepting states. तो अगर मैं आपको बोल रही हूँ set of final state, it means DFA में एक से ज्यादा final state हो सकती है, and that is why DFA, that final state is a subset of set of states. Okay, so here is a very simple example, on and off switch. Suppose इनिशियली आपका फैन ऑफ रहता है, और यू कैन सी ट्यूबलाइट, कोई भी इलेक्ट्रिकल अप्लायंस ले लीजिए. फर्स्ट वो आपका कौन सी पोजीशन पे होता है, कौन सी स्टेट पे होता है, वो आपका ऑफ स्टेट पे होता है, विच इज द इनिशियल स्टेट. ओके, व्हेन यू पुश द बटन, इट गोज टू द ऑन स्टेट, विच इज द फाइनल स्टेट. फाइनल स्टेट से अगेन व्हेन यू पुश द बटन, इट रीच टू द ऑफ स्टेट. सो हियर push is the transition, and on and off are the two states, in which off is the initial state and on is the final state. So so you always start with the initial state. So this is the transition table. Here we have two states, on and off, and this arrow represent that this is the initial state, and the star represent this is the final state. So when you are in the off state, जब आप off state में हो, आपने input दिया push button, आपने input दिया push button, it leads to आप कौन सी state पे गए, आप ऑन स्टेट में चले गए. सेम जब आप ऑन स्टेट में हो, दिस इज द फाइनल स्टेट, आपने पुश बटन, आपने पुश किया, एंड यू लीड टू द ऑफ स्टेट. So this is how transition works. This is called it as a transition table. Okay, this is called it as a transition table. Okay, so this is one of the simple example of DFA machine. Okay, so now let's revise it again, and after that we will consider the examples of DFA, and you will understand it better. So we have discussed so far about the basic elements of finite automata, which is symbols, alphabet, strings, and languages. And then we have discussed about the power of alphabet, which is very important. So here we have taken the two symbols from the symbols. So that is why here we have two. तभी हम यहाँ पे two की power लिख रहे हैं, because we have taken two symbols. अगर आप three symbols लोगे for the alphabet, you have to use 3 की power 1, 3 power 2, 3 power 3, like this. So now this is the clean closure. Clean closure includes the epsilon, and positive closure does not include the epsilon. After that, we have discussed the division of finite automata, which is the with output and without output. With output, we have Mealy and Murray machine. Without output, we have NFAs, DFAs. NFA is non-deterministic finite automata, and we have deterministic finite automata, and we have epsilon NFA. This symbol is called epsilon NFA. So we have discussed about the definition of this. DFA has a less memory, and DFA is without output machine. It always recognize the acceptability of the string. And we have a 5 tuple DFA definition, which contains set of states which denoted as Q, and a finite input alphabet. Then we have an initial state, then we have a transition function, then we have a set of final states, and after that we have covered this simple example about the states: initial state, final state, and the push button. Okay, so thank you so much. I will cover the next topic about the DFA questions in the next lecture. Thank you.